Cyclops is dumb. Not because he isn't a cool character, but because the way the comics describe his powers is just silly. According to Google, Cyclops' optic blasts are not lasers. They are pure kinetic energy pouring out of his eyes as portals from a non-Einsteinian dimension called the punch dimension. Sounds less like theoretical physics and more like a rejected Mario level. What a load of gobbledygook. I guess the writers didn't want a classic laser eyes superpower, but if by pure kinetic energy you mean energy carried entirely by motion, then lasers are pure kinetic energy. Let me explain. There's often a lot of confusion in physics about energy, kinetic energy, and light, because people usually only see half the picture. You've probably seen the classical definition of kinetic energy, 1/2 mass times speed squared. You've also probably seen Einstein's famous equation, E equals mc squared. What you may not know is that these are both approximations of one larger equation. What Einstein discovered with special relativity, you can check out my video on special relativity here, is that energy is related not just to rest mass, but also to momentum. If I write momentum in terms of velocity and expand this equation for speeds much less than the speed of light, it reproduces both the familiar rest energy term and the classical kinetic energy formula. So the classical equations you've probably seen are really just approximations of this more fundamental one. But note this still requires a notion of mass, and light is massless. Therefore, it has no kinetic energy, right? This is only because I defined momentum from our classical, not relativistic description, which needed mass. In relativity, momentum is more complicated than just mass times velocity. Instead, energy and momentum are linked by this equation. Every particle we know must obey special relativity, and thus this equation. Since light is massless, and importantly, has energy, it must have momentum. Since this entire energy comes from its motion rather than rest mass, you can loosely think of light's energy as being entirely kinetic. So yeah, Cyclops, you shoot lasers. But how does Cyclops' optic blast feel like punches then, or carry a concussive force? Since light has momentum, it also obeys conservation of momentum, so when light hits a surface, as it reflects or gets absorbed, it can transfer this momentum, which acts like a pushing force. This is actually a well-documented phenomenon, and it's the mechanism behind one of the most popular space travel ideas, light sails. So the natural question is, how hard does Cyclops hit with his optic blasts? Quantum mechanics state that light is both particles, called photons, and electromagnetic waves at the same time. The energy of a photon is proportional to the light wave's frequency, and by this relationship, the momentum is proportional to the light wave's wavelength. So by analyzing the color of Cyclops' optic blast, we can calculate its energy. There could of course be higher frequency light not visible to us, but we'll assume that the lasers in Cyclops' optic blast are made of one frequency. It looks about 700 nanometers, which is deep red, so the energy of a photon becomes around 2.8 times 10 to the negative 19 joules. For reference, a punch from Mike Tyson has about 1600 joules of energy. But don't fret. The total energy of a laser doesn't come from a single photon. It comes from an enormous number of photons traveling together. The brighter the laser, the more photons it contains. If we assume that Cyclops' blasts have at least the same energy as Mike Tyson's punch, this means that for every blast, Cyclops releases about 6 sextillion photons, which is around the same number that hits your body as you stand in direct sunlight. So there, Cyclops shoot lasers. Take that, X-Men writer Chris Claremont. In fact, we can go further and explain why Cyclops' visor works. In solid-state physics, some crystals have a photonic band gap. The crystal's internal structure causes certain wavelengths of light to destructively interfere, leading to no optical transmission. For ordinary light levels, whether the crystal blocks light depends primarily on wavelength rather than intensity. And since the wavelength of Cyclops' light is quite realistic, it is theoretically possible to make glasses that stop the lasers from coming out of Cyclops' eyes. It would make him effectively blind to red, though, and ruby, which is used in the comics, does not have this photonic bandgap structure. So despite what decades of comics insist, Cyclops doesn't shoot pure kinetic energy. He shoots something that behaves exactly like light, carries momentum exactly like light, transfers force exactly like light, and whose energy is completely explained by the equations that describe light. In other words, Cyclops shoots lasers. Sorry, Marvel. Thanks for watching. If you'd like to see more physics of superpowers, please like, comment, and subscribe.